So now we're going to do the third method that we use to solve quadratic equation, and that's called completing the square. Completing the square is a matter of just trying to write a quadratic equation in the form that we had in our second method, which was using the square rule, where you get the plus or minus square root thing. So we need to have a binomial squared on the left side of the equation, and on the right side just a number. And the process of taking a quadratic equation and putting it into that form, if it doesn't start in that form, is called completing the square. Okay. So recall that if we square a binomial, this is actually what's called the binomial formula for squares. You have a binomial x plus b, and you're squaring that binomial. You end up getting the first term squared, this term here, squared, plus twice the product of these two, which is 2bx, because we usually write the constant first, plus b squared. So you see the first one squared, twice the product of the two, 2bx, and then b squared. So if we had a polynomial in this form, x squared plus some number plus half of this number squared, then we would know we could just write that this way. Now, why would we want to do that? Well, we're trying to put it in that form for the square rule, which is like this thing equals some number. That's one way to think of it. Another way to think of it is this has two different terms with an x in it. If you try to solve for x directly, which one are you going to solve for? I mean, that's not going to work out. You'll have an x equals something with an x in it. It doesn't tell you what the number x is, right? So we have to get this down to 1x. One way to do that would be to factor this. If we had a trinomial that factored, we could factor it. You'd have it equal to 0. Then you set each factor equal to 0. That's method 1, right? And the reason that works is because you're splitting one equation that's a second degree equation into two equations that are first degree equations, which means that there's only one term with an x in it. And then you solve each one separately. But notice also another way is if you go from right to left on this, which is really just factoring this, you get only one place where there's an x. And then you can solve for this x. So that's why we kind of like this form here better than this. Okay? So we want to apply this formula, this quadratic formula, this binomial formula for squares to a quadratic equation, but reading it right to left. You know that we're doing it backwards. We'll start with a trinomial and turn it into this x plus some number, the quantity squared. Okay? And we're going to start this with leading coefficient 1. Because you actually always do this with leading coefficient 1. If there's some other leading coefficient, you either factor it out or divide it out. So we do this with leading coefficient 1. Why? Because then the middle term, the coefficient of x is just 2b. If there's a coefficient on the x over here, like 3x plus b or something, then that 3 would get included in here too, and it just makes it more complicated. So we just want to have a single x squared here. In other words, we just want a leading coefficient of 1. So that's what I've got here. I've just got some random trinomial. Now this is not necessarily, this is going to be 2 times the capital B, this big blue B here. So these first two terms are exactly the same as these first two terms on the left. The problem is, so notice that means that this capital B is half of this little b. It's kind of weird that the big one's smaller than the little one, but that's okay. But then if we square that, we're probably not actually going to get c. And so we have to adjust c to make it equal to b squared in order for it to factor like this. Okay. But if it was equal to this, then you would just factor it like that, and then you'd be all set. Right? So then we would just use the square rule from the second method, which is the thing where you end up with the plus or minus square root. Notice that the purple b, little b, equals 2 times big blue b. So big blue b equals little purple b over 2. Okay, it's 1/2 of it. I cross-multiplied the 2 on the first equation here. Right, you just put the 2 down there on the other side of the equation, or divide both sides by 2, same thing. And you just get this, right? So this b is half of this b. So if I'm given some trinomial with a leading coefficient 1, I can immediately see what this b in here should be. It should be half of this. So I would write down this half. You'll see how I write them down when I do an example. I would suggest you write it down exactly the same way. And just do that every time. And then you won't forget later how to do this. Like if you had to do it in another problem, which you will in another section. Actually, there's a few sections we have to do it in. And then we also have to do this completing the square on the final exam. So there you go. You want to remember it. So again, the problem here is that this little c here is usually not actually, oops, where am I? This pointer's a little weird. This little c here is not usually b squared. We'd be lucky if it was b squared, right? So we need to introduce b squared into whatever your equation. You'll have this equals 0. You have to introduce b squared in there. And the way we do that is just by adding b squared to both sides of the equation, at least when solving a quadratic equation. For quadratic functions, we do it a little differently. So we'll do that later. So doing that's called completing the square. You just put that b squared in, and then you'll have a trinomial that factors as x plus b, the quantity squared. So here's an example. That's a lot of words. It might be kind of hard to figure out what the heck I'm talking about. If you understood part of that, that's great. Don't stress too much about it. But you need to understand how to do these problems. So I'm just going to do some examples. So suppose you're solving x squared plus 4x plus 1 equals 0. That's a quadratic equation with a leading coefficient of 1, right? So I can use this method that I showed you up above. So first I have to figure out what the big blue b is, right? 4 is the little b. The big is the coefficient of the middle term, x. So the big blue b is 2. So write it down. So, oh, I forgot. First you don't have to do this first, but I decided to do this first. I just moved the constant term to the other side just to get it out of the way. It's not necessary, but I wanted to get it out of the way. So if you move it to the other side, it becomes minus 1. In other words, subtract 1 from both sides and you get minus 1 on the right if you're still doing that. Okay, then write down what b is. Now I just wrote 4 over 2 so you could see where it was coming from. I'm dividing the coefficient of the middle term by 2. And I get 2, obviously. So my big B is 2. So now I need a B square. Remember? Right here. I want this. I've got this. Because 4 is 2 times the blue B. The blue 2, right? Which is the 4. I'm just missing the b squared. So I need to put b squared in here. And if I put b squared in here, I have to put b squared over here too, so that my equation is balanced, right? So the value on the left still equals the value on the right. So I'm going to add 4 to both sides. But first I would write down what b squared is. And always do this. Write down these things. Write this down. You don't have to write the middle one because you can probably divide this by 2 without writing it down. But write b equals 2. B squared equals that squared, right? 4. And then write the 4 in there and there. Notice when I wrote this out, I left a space here. I left a space for this 4. Right? And you can always do that, just leave a space there. Okay? So I'm going over this kind of slowly because it's important that you get it right. And it's kind of a long algorithm. And so some people have trouble getting it down. I've had pretty good luck recently with most of the students at least getting this. Some of them are better at this than they are at factoring, which is interesting. Okay, so I added 4 to both sides. Now what am I doing here? Well, the right side, 4 minus 1 is just 3, so I wrote down the 3, right? And then we've got, what is this? Well, remember this trinomial is this thing. So it factors this way. So I'm just going to write x plus b, the quantity squared. And I already know what b is. I wrote it down. See, you're using this twice. That's why you write it down. So I'm going to have x plus 2 there. The quantity squared equals 3. Okay? Now I've completed the square. That's in the form that we had in our method 2, which is the square rule. So now I'm just going to drop the square from the left, and I'll get a plus or minus square root on the right of the whole right side, which is just a 3. Right? Drop the square on the left, you get a plus or minus square root on the right. And then, if you take the 2 term off the left, you'll get a negative 2 term on the right. It's just the opposite, right? In other words, subtract 2 from both sides if you're still stuck with that. Okay, that's the first example. That's the whole method here, really. I'm going to do at least one more example, maybe more, on the next video or two.